Welcome, my name is Dr. DrWedding, and this is DrWedding, DC02. Engineering Notation and Metric Notation. This video will cover how to convert a value into engineering notation and then into metric notation. It is important to understand engineering and metric notation because the components used in electric circuits are often listed in metric notation. As humans, we are used to writing numbers in the form we were taught in the second grade. This is called standard notation. Almost everyone would recognize and have a good idea of what the following list of numbers represents. But that is not the only way we can write a number. If you have taken a class in physics, chemistry, or astronomy, you probably have written numbers in scientific notation. Scientific notation has one rule. The number must be written so there is only one value in front of the decimal point. Here is an example. Assume you have 52,800,000 and you want to convert it into scientific notation. Scientific notation states that there can only be one value in front of the decimal point, so this value would become 5.28. Obviously, these numbers are not the same. To make them the same, the 5.28 needs to be multiplied by 10, multiple times, until you get back to the original number. Because you need to multiply 5.28 by 10 7 times in a row to get back to the original number. It is written as 5.28 times 10 to the 7th power. Writing out all the steps, as shown here, is a lot of work. It is easier to get the scientific notation of a number if you just count the number of places the decimal point needs to move to get the original number back. In this example, the decimal point needs to move 7 spaces, so this is represented by the 10 to the 7th power. You may be wondering what you need to do if the number is less than 1. You just apply the same rules as before. Assume you have 0.00033 and you need to put it into scientific notation. First, you put one value in front of the decimal point and the number becomes 3.3. Next, you need to multiply the 3.3 by 10 some number of times to make it equal to the original number. But this is a problem because multiplying by 10 will make this number bigger and it needs to become smaller. Instead of multiplying by 10, you need to divide by 10 to get the original value. The decimal point needs to move 4 spaces to the left, so the power on the 10 is 4. Even though these values are equivalent, this is not the proper format. We still need to multiply by a power of 10 and not divide. Division is the same as multiplying by the reciprocal. That means instead of dividing by 10 to the 4th power, you can multiply by 1 over 10 to the 4th power. Furthermore, you can rewrite the 1 over 10 to the 4th power as 10 to the negative 4th power. This means if you want to multiply by 10, you use a positive power. And if you want to divide by 10, you use a negative power. This slide has 4 problems on it. Feel free to pause the video and try to do these on your own. After you have solved them, resume the video to see the solutions. Scientific notation and engineering notation are similar, but not the same. A value written in scientific notation can only be written one way. But a value written in engineering notation can be written in an infinite number of ways, and they are all equally correct. The rule for engineering notation is: the exponent on the 10 must be an integer multiple of 3. That is just a fancy way to say it will be a positive or negative 3, or 6, or 9, or 12, and so on. In engineering notation, the number of digits in front of the decimal point no longer matters. The only value that matters is the exponent on the 10. Let's look at an example. Assume you have the number 17,000 and you want to convert it to engineering notation. We can only move the decimal point in groups of 3. So let's start off easy and move the decimal point 3 places to the left. This leaves us with 17. 17 is smaller than 17,000, so we need to multiply by 10 3 times to make it equal to the original number. So one way to represent this value in engineering notation is 17 times 10 to the third power. We could have also moved the decimal point 6 places to the left, because 6 is a multiple of 3. When the decimal point moves 6 places, we are left with 0.017. By moving the decimal point, the value got smaller. To make 0.017 equal to the original 17,000, we would need to multiply by 10 6 times. So another possible answer is 0.017 times 10 to the 6th power. We could have moved the decimal point 3 places to the right instead of to the left. This will make our value increase from 17,000 to 17 million. By moving our decimal point to the right, our value got bigger. To make it match the original value, we need to divide by 10 3 times. So another possible answer is 17 million times 10 to the negative 3 power. Here are a few possible ways you can write 17,000 in engineering notation. They are all equally correct. At this point, you may be wondering, why can a number be written in so many different ways, and why would you ever want to write a value like 0.0000017 times 10 to the 9th power? Well, imagine you have a schematic with many different resistors on it. If the resistors were in scientific notation, there is only one value in front of the decimal point, so you would be constantly checking the power of 10 to determine the value. This would increase the chance of you making an error because you looked at the exponent incorrectly. The problem could be even worse if you missed a negative sign on one of the powers and you increased the value instead of decreasing it. These values that were in scientific notation have now been converted to engineering notation, and they are all set to 10 to the third power. It is very easy to see which values are large and which values are small. The chance you will make a magnitude error is greatly reduced. This is the last numeric notation that we will cover in this video, but it is the most important to know. It is metric notation. Metric notation is just an efficient version of engineering notation. These two notations are calculated the same way. The only difference is that in metric notation, the times 10 to some power is replaced with a single letter. For example, the engineering notation value, 3.14 times 10 to the third power, is written in metric notation as 3.14K. The only new information you need to know is what letter you need to substitute for which times 10 multiplier. In this chart, it has some of the multipliers and the letter that is used to replace it. Start at the one in the middle of the chart. As you go to the right and continue on the lines below, the multipliers are positive and increasing. These are when you are multiplying by 10 to get a larger number. With the exception of kilo, all the positive multipliers are capital letters. Now, go back to the one in the middle of the chart. If you move to the left and continue to the rows above the center, the values have a negative power of 10. These are used when you are dividing by 10 to get a smaller number. All of these numbers are lowercase letters with one exception. Micro is the Greek letter mu. If a device such as a typewriter or a computer system does not have access to the Greek letters, lowercase u is often used in place of mu. So, you will see both lowercase u and mu in use. You will need to know and commit some of this chart to memory. I would suggest learning it a little at a time, starting in the middle of the chart at the 1 and work your way out. Start by memorizing the plus 3 and minus 3 powers, kilo and milli. Next, memorize the plus 6 and minus 6 powers, mega and micro. Continue on until you have learned the middle 3 rows of this chart. Most of what you will use will fall between pico and tera, but if you are ambitious, you can learn all of this chart. And if you are an extreme overachiever, you can look up the complete chart on the internet and memorize all of the multipliers. As previously stated, metric notation is just a simplified version of engineering notation. Shown here is a list of 4 values in standard notation. Next to each value, there are 2 versions of the same number in engineering notation. You may wish to pause the video so you can try to convert the values from engineering notation into metric notation. The converted values will be given after you restart the video. The values that were written in engineering notation have been converted into metric notation. For example, the first value, in the first row, had the times 10 to the 6th power replaced with a capital M. And the second value, in the first row, had the times 10 to the 3rd power replaced with a lowercase k. If you use the metric notation chart that was supplied in this video, you should easily be able to substitute the multipliers with the correct letter. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.